Okay, so we're going to do another rate law problem, and then we're going to start talking about this idea of mechanisms and how the reaction actually happens. A lot of times, it's not just a one-step reaction, but more a series of steps, and one of these steps goes slower than the others, and that's called the rate determining step. So we're first going to start out looking at this right here. So here's a reaction. 2x plus y is z. And they give us our trials here. So the first thing I'm going to do is I'm going to look at x. And to do x, I'm going to do 2 and 3 because x doubles, y stays the same, and the rate in 2 and 3 stays the same. So you can see that there, that rate. When we double it here, that rate stays the same. So that would be 2x equals 1, x equals 0. So in this case, reactant x doesn't have an effect on the rate of the reaction. Zero order reactant, don't have to put it in the rate law. So I'm starting my rate law. Rate equals k because there's always a rate constant. Now let's look at y. Y is pretty simple here. We've just got a doubling of y and then a doubling of the rate when x stays the same. So that's going to be 2x equals 2, x equals 1. So our rate law is pretty simple. It's just k and then reactant y, first order, really simple to do. Now we want to come up with the value of the constant and the unit. Now, since it's a first order reaction, the unit's easy. It's going to be 1 over seconds. I'm going to just pick the first one here and plug in. So 7 times 10 to the negative fourth molarity second. And then k, and then my y is going to be 0.10. Divide both sides by 0.10. And so my k is going to be 7.0 times 10 to the negative 3 molar per second. Sorry. I had the molarity per second from the rate. You divide it by the molarity there, and that's going to give you 1 over seconds. So that is my k right there. So the rate law is rate equals 7.0 times 10 to the negative third. And the unit is 1 over seconds. I know that's hard to wrap your head around a little bit. And then just molar concentration of y. So now we have it set up that it doesn't matter what molar concentration of y we have, we could figure out the rate for that reaction. Now, the next step they give us is they want to figure out, if they give us these series of steps, these mechanisms, which mechanism will be the correct one. And so, you propose, oh, well, this happens and then this happens. Okay, so let's look at the first one here. So mechanism 1, the M is an intermediate. It is something that is formed and consumed in the reaction. It crosses off because you see it's a reactant here and a product here, even though my arrow is real sad looking. Let's see if I can fix that just a little bit. You see that he is a product here and a reactant here. So, cross him off, okay. And then when you add these two steps, it should give you the original equation, 2x plus y yields z. So let's do that. So I got an x in the first step, x in the second step. That's cool. Plus y yields z. Okay, so this one passes the first test. Now let's look at the predicted rate. So anything that's a reactant gets to be in the rate law. Now here, this slow and you always pick the rate law, predicted rate law from the slow step. So the rate law predicted by this is going to be rate equals K. And since the X and Y are there, it's going to be X, Y. Now we know from doing our problem that X is a zero order reactant. So mechanism 1, I don't think so. Not going to happen. Okay, so now let's look at mechanism 2. All right, so mechanism 2, you see that M for the intermediate again there. So let's cross this sucker out. Okay, so I got an X and a Y, so I got X plus Y yields Z. Well, that's not going to work for me, and here's why. I'm short an X. So if I'm given that the equation is 2x plus y, and my mechanism doesn't add up to 2x plus y, I'll tell you what, friend, you got the wrong mechanism. Let's hope 3 works out here. Now 3 is a 3-step mechanism. You see that it actually has 2 intermediates. Well, let's see if it adds up correctly. Okay, so you got M crossing off with M, N crossing off with N, you got a Y, you got 2 X's, making a Z, good. Okay, so it does follow the first, it passes the first test because it's the same here. It doesn't matter that the 2x is second and the y's first. It doesn't matter. Okay, so, but we do have that same equation right here. Now, look at the slow step. And from the slow step, the only thing in the slow step is y. And so, rate equals K times the concentration of reactant y. That is our predicted rate law from this mechanism. And looky, it matches here, and it matches there. So, ding, 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 this is the one that we want. And that is how you do a mechanism like that. So just remember that all the steps in your mechanism have to add up to the overall reaction. Intermediates get crossed off. Those are things that are produced and consumed in the reaction. Don't confuse them with catalysts, which are there at the beginning and then get spit out at the end. And remember to always predict your rate law off the slow step.